Hey Sam, just going to give you some test advice. Take it for a grain of salt if you want to. Obviously you're smarter than I am when it comes to these tests, but let's think about this. You got 12 problems you have to do. Obviously, my advice would be as soon as you get in there is identify 5 to 6 problems that you're going to spend most of your time, at least 80% of your time on, until you got the answers right. Obviously, look around for things you're comfortable with. Leave the other ones alone. Things that I think are going to be, things I would know tonight. I would make sure that I know that normal stress is going to be just P over A. And again, this is average stress. And then I would make sure that I know that shear stress average is also going to be P over A. I'd make sure I know that. Now, make sure that when you get into bending type problems that you have MC over I, meaning that if you have a cross section like a beam here, first thing you're going to do is identify your C value. Your C value is going to be any distance from the neutral axis, or where the center is, out. That's going to be your C value coming out. If I find out if this is my C, then that C is going to give me the stress right at this location along this surface right here. If I pick C to be here, it's going to give me the stress anywhere along here. Now, if you get into problems like VQ, like maximum shear at any point, you're going to do VQ over IT. And so let's just grab a cross section here. Again, the same thing you're going to do is identify your neutral axis. Now, if the question says, what is the shear stress right there, then to get your Q value, you're going to have to come and draw your line right here, and your Q value is going to be this area in here, okay, times the distance from the center of that back to the neutral axis. This is your Y bar. So it's going to be area times Y bar. That's going to give you your Q value. And that's going to give you your stress at this point here. At the outer edge, you have no shear stress because your area disappears. Your thickness in all these cases is going to be this value right here. Okay, so make sure that you know that. Other things that I would probably look at tonight would be, again, make sure that you know that shear stress due to torque is going to be equal to your torque times R times the polar moment inertia. So make sure you identify those type of problems. Make sure that you can set it that when you have a complex problem, that you go back to my video and watch that and make sure you can solve that with the matrices. It's going to make your life a lot easier in doing anything where you have combined stresses. I would also review the deflection and the stress, or the deflection due to thermal temperature changes. I did a couple videos on those. I'd watch those and make sure that you know how to calculate what the stresses are going to be as a result of that. I would look over the deflection type problems that you know that deflection is equal to PL over AE. Make sure you completely know those, that you can apply it to most problems. Trying to think other things I would work on tonight. And again, please don't take this wrong. It's just my opinion. I would make sure that I know how to do shear and moment diagrams. May not be on the test, but there may be questions on the test that's going to help you identify that. I know when you and I worked together in the past, you were very, very good at shear and moment diagrams. That would be useful to you, especially finding your reaction forces. So I would look over that. Let's try to think other things that I would look at. Obviously, bending stress, as I mentioned earlier, the MCRI, make sure you can do those type of problems. I would think there probably might be something where you have a combined problem where you have deflection, and you're going to end up using the PL over AU with two different materials. I'd look into that. Nope, hang on a second. I would look back into Chapter 9. I would think, maybe I'm wrong, that there might be one or two problems in that. You have the calculator program to work those. Just make sure that when, I know in the prior test that when it was oriented differently, just make sure that if it's rotating this way, that you know what to put in your calculator. Make sure you can do more circle. There's plenty of videos on that. I'd watch those. Trying to think anything else I would probably look at here. I don't know if I'd mess around much with Chapter 11. I would make sure in Chapter 12 that you know how to do the first and second derivatives and how to find your boundary conditions. There's lots of videos I did on that. And the only other thing I would probably look at this point in time two other things would be the ones using the tables. Anytime you sum a moment and you have two unknowns, you're going to have to go back to the tables. There's going to be no way to solve that. Because if you get two equations, three unknowns, you're stuck in the water. You're going to have to do something. And then I would spend some time on columns. If you get a column problem, it's going to be a very, very easy problem. All right, in concluding, again, I think you're going to do quite well in this test. The main thing is stay focused, which I know you're going to. It's going to be, I'm sure it's going to be a very hard test. I would go in with the attitude and the mental attitude that's going to be a pain in the ass, and you're going to have to just keep focused, and even when you can't get the right answers, and just put all your energy into those 5 or 6 problems until you get those done, and then I would move on to the other problems and at least show some work. If you're going to guess, show some work, because just think in your mind, these people that are checking this are going to have a day or two to check all these, and if they get the right answer and there's some work, they're probably going to give you credit. Anyway, sir, best of luck. Again, this is just my opinion.